This is 8.2. Law of cosines. So the first theorem, C is equal to the square root of a squared plus b squared minus 2ab cosine of c. And all of this is inside some triangle. It looks like this. We got angle C here, angle B over here, angle A. Oh, capital. Capital for the angles. So we said last time. The second one is you want to solve for B, side B. That would be a squared plus c squared minus 2ac cosine capital B. So I went ahead and solved for ABC for you. That way all you had to do is plug stuff in. So this is b squared plus c squared minus 2bc cosine of A. Okay. Next formula. These are to solve for the angles. So let me make some space. So this is the sides. Now the angles. Capital A is equal to cosine inverse of b squared plus c squared minus 2bc cosine. Oh crap, sorry. Writing down the one up top. B squared plus c squared minus minus a squared over 2bc. The angle B is equal to the inverse cosine of a squared plus c squared minus b squared over 2ac. Ouch. Bit me. A squared plus b squared minus c squared over 2ab. Okay. So those are all the formulas you're going to need today for block science. So similar to the last section, you're just going to solve the triangle. Let me pick one. So I think if someone will give you the picture. So I'm going to put the picture, I guess, on the right side. I can use this spot for work. Again, my triangles are not to scale. They're not all isosceles. They just look that way. So we're not given A or B. We're given angle C to be 106 degrees. We got this side and we got that side. We do not know what little c is. Okay. I'm going to write down everything I do know. So we got side A and side B. And that's all I got. I'll wait a bit. So do you see why we had to do log cosines? Right. Last time we were doing law of sines, we had case 1 and case 2 for law of sines. And we said that we have to do law of cosines when you're not given any opposite side. See how we have an angle, but no opposite side? Here we have some sides, but no angles that are opposite to them. So we have no choice but to do law of cosine. So let's do it. So I'm going to find angle C or side C. That way I can then find these angles. Okay, so the little c is equal to the square root of a squared plus b squared minus 2ab cosine c. So that means that this will be equal to, just plug it all in, a squared b squared minus 2 times 4 times cosine 106. So just plug in 2ab cosine c. So we're going to have to get a calculator. There's no way around it. Okay. Second square root of 2 squared plus 4 squared minus 2 times 4 cosine 106. I don't know if I'm in degrees. Yeah, we're good. So side C is 4.94. Okay. So now we need to find at least one angle. That way we can just subtract from 180, right? And we're done. Any questions about little c so far? Right, well, capital B is equal to cosine inverse of where is it? Yeah, there it is. A squared plus c squared minus b squared over 2ac. This pen running out? Yes. Okay. So that would be cosine inverse of 2 squared plus 4.94 squared minus 4 squared over 2 times A times C. So once you have all three sides, you can solve for any angle you want, but you have to have all the sides.
So you said for the calculator part, we have to be in degrees for this or no?
I'm using degrees because they gave us degrees. But it depends on the question. Like if you know, if they're not giving you any degrees, then yeah, switch over. But I think they should mostly be for these type at least. But either or is fair game. Okay, so let's figure it out. Cosine inverse. What's up?
I'm trying to figure this out because I'm
You're just coming
getting
out.
some really weird answers. Yes.
Let's see. Are you in degrees?
Tried it in degrees and I've tried it in radians and I've tried going to decimal degrees and I don't know if you can see that.
Let's see. Square root. Is that a negative in front?
So like the very bottom one is,
Oh, okay. Move it up just a
and
little.
then if I hit enter, I get that answer.
Let me see. 2 squared plus 4 squared minus 2 times 4. Oh, I see what they're doing. They're giving you the exact answer. They're not giving you the decimal. You see what I mean?
Yeah.
So you can you force it to give you a decimal, or is there a setting you can change it to always be in decimal?
Well, and that's I tried that, convert to decimal. So see that, answer to decimal. Somewhere around there's an enter button. Enter. Then I get that really weird thing.
So what does it say? Point. What?
0.133 repeated times square root of 15, negative 15.708
Yeah, it looks like it
something.
didn't completely give you the decimal. That's weird. There's got to be a setting that doesn't give you exact answers in there, or maybe put it in parentheses and then do decimal. Because it seems like it's only doing decimal for part of it, which is weird. Let me see.
I was using the wrong calculator.
Whatever.
I have one that's a CAS and one that's not.
Yeah. Yeah, the CS is the one that I'd rather you didn't use. But the other one
Well,
worked.
to be fair, they're both blue.
That's funny.
I'm stupid. I try not to use that one because it makes me feel even dumber than I am.
Yeah, it's like it does too much, I think, right?
Never mind. You can keep going. I'm good. Okay.
Okay. Okay. Let's keep going. All right, so we got we gotta plug this guy. That's what we're doing. So 2 squared plus 4.94 squared minus 4 squared over 2 times 2 times 4.94. So the angle looks like 51. Point 12. Yeah. And if you have both of those, just subtract from 180. 180 minus 51.12 minus 106. So the last angle will be 22.88 degrees. So A will be equal to 180 minus 51.12 minus 106, which gave us 22.88. Any questions on example 1? So this is case 3. Let's move on to a different one. Let's do the suitcase 4, where all we have is sides. You guys cool on this page?
No, wait. Go back.
Okay.
Two squared. Oh, wait. That's what I'm doing.
sir?
Yes.
Double checking. Law of cosines applies to all triangles, whether they're right angles or not, right?
Right.
Okay.
If you try to use this on a right angle,
Two
this
plus
part,
4.
this part will zero out,
So it'll still work.
leaving you with a squared plus b squared.
Okay.
Right, that's why c squared would be equal to a squared, right? So if you solve for c, you'd only have this piece. So this additional piece is taking care of non-right triangles. But if you have one, well, it'll vanish.
Interesting. Thank you, sir.
Because cosine of 90 is 0, right? So 0 times all this stuff would be 0. So just be this.
Oh, wait, no, I got it. I'm good.
Cool.
Thank you. I'm having technology issues today, apparently.
One of those days, I guess. Oh, it's Friday though. So that's cool. Solve the triangle. So I'm not going to give you a picture this time, it's just missing pieces. A is 3, B is 5, C is 7. So notice that we have no angles, so we have no choice but to use law of cosines. So let's find capital A first, I guess. So capital A is cosine inverse. If we look at the formula, it should be b squared plus c squared minus a squared over 2bc, which will be cosine inverse of 5 squared plus 7 squared minus 3 squared. So that'll be 2 times 5 times 7. Okay. So that's approximately, I don't know, something. So five squared plus 7 squared minus 3 squared over 2 times 5 times 7. So one angle is 21.79 degrees. Angle A is 21.79 degrees. So now let's do this again with B, the formula for angle B. Cosine inverse will equal a squared plus c squared minus b squared over 2ac, which is equal to cosine inverse of 3 squared plus 7 squared minus 5 squared. over 2 times A times C. There we go. Okay, so do it again. Into the machine. Oops. My fat fingers. Three squared plus 7 squared minus 5 squared over 2 times 3 times 7. That will be 38.21 degrees. Now that we have two angles, the last one is pretty much given to us. C will be equal to 180 minus the other two angles, 21.79 minus 38.71. Which is like 120, right? Just about.
Sure. Did you write 38.71 instead of 21?
Here, right?
Mm-hmm.
Yeah, I did. Any questions on example 2?
Good to go on that one.
Is it pretty straightforward? Now, in this section, you can use log signs whenever you want, if you have the right pieces, of course. If you want to use log cosine, that's fine. The beauty of case 3 and case 4 is that you will only have one triangle. Because if you have all three sides, then that means a triangle exists, right? One triangle exists. So that's case 4. In case 3, we had let's see. We have two sides and an angle. So that one was pretty much given. So whenever it's a log cosine problem, it's going to be one triangle. When you have case, I think it's 2 is when you have a possibility of multiple or no triangles. Let's look at our homework. Okay, so it starts off with some definitions. Let's skip that stuff. Question 4 is like the one we just did. Notice how we have nothing but sides. So you'll have to find, I think it's the exact same one actually. Check those numbers out. Crazy. How random. And number 5. This is like the first one we did. See how we have two sides, but no opposite side to an angle, forcing us to do log cosines. So this is case 3. Okay. Case 4. Let's see here. If you look at this one, do you see why you have to use log cosines?
Because there's no opposite side for the angle.
Yeah, there's no, we need little b, right, to do it. So yeah, and then over here, law of sines is recommended because we have an opposite side and an angle, right? Although when you try to solve it, you're going to get an error, like we talked about last time. Remember how you get a error on your calculator? That means it's impossible to solve. Anyway, is this idea making sense? Is it straightforward or is it weird? You can't tell.
It's pretty straightforward.
Okay.
What about finding the area of a triangle?
Area. Oh yeah, I'm glad you mentioned it. Let's talk about it. Where is my? Well, actually, I already have it memorized. One. Interesting. Okay, sorry, got distracted. So area of a triangle. Well, what I recommend, at least for me, the easiest way to go about it is use Hero's formula, spelled Heron. So all you have to do is find all the sides. So area will be equal to the square root of s times a minus s. Oops, I got it backwards. S minus a. Excuse me. S minus b. S minus c, where s is equal to half of all the sides added together. So the sum of all the sides divided by 2. So if we try to find the area of, let's say, example 2, triangle in example 2, all we need is the sides. So a is equal to 3, b is equal to 5, c is equal to 7. So we're going to need s. So s is equal to 3 plus 5 plus 7 divided by 2, which is 15 over 2, right? 7.5. Okay. So the area will be the square root of 7.5 times 7.5 minus 3 times 7.5 minus 5 times 7.5 minus 7. So that's approximately something. The area will be 6.49 or 6.5. So that's the one I would use for area. There's some other formulas you can use for if you're missing sides, but you can always find them and just use this, but I'll go ahead and give them to you if you choose to use them. So I'm going to call it the area K. So let's say K is the area. So that'll be 1/2 times A times B sine of C. Number 2, K will equal 1/2 times B times C sine of A. And the last one, K is equal to 1/2 A times C sine of B. Where A, B, C are sides of a triangle, and capital A, B, C are its angles. Okay, so let's look at the homework again. Okay, so I think this corner will be pretty chill. This word problem is pretty easy. Let's see here. Let me see if it's worth keeping it on here or not. Yeah, that's pretty chill. I guess, do you have any questions on the section? You want to do another problem? Is it making sense? Is it weird? Or do you guys have some homework problems you want to work on? That's all I have for you here today. I'm not going to start the next section just yet. But we have some extra time if you're struggling with anything.
If nobody else has anything, I'd love to talk to you about some homework stuff,
Yeah, sure.
but I'll wait until everybody else, is done.
Well, if you guys have no questions, you're welcome to head out. And if you want to stay around and do some problems, you are all welcome to.
I was gonna stay to watch too.
Okay. So, you know, which problem do you want to work on? Or,
Okay, sir. Sorry, I sound really hoarse. I'm still sick, by the way.
oh, that sucks.
Yeah, it does. I'm really hoping it's not like COVID or tuberculosis and that it's just regular cold, but it's hard to tell with my job.
Why not both? I'm just kidding.
It could be actually, yeah. So I'm catching up on classwork, like I told you.
Okay.
I'm about halfway caught up on all the stuff I haven't done, and I caught up with it all today, which is pretty cool.
Nice.
I know, right? Like half the chapters between the first test and this upcoming test in one day.
Yeah, it sounds rough.
Well, it's the only day I've really had to work on it.
Hmm.
Anyways, so I'm working right now on chapter 7.2,
Okay.
and it's verifying stuff, you know, like
Yeah.
verifying the identities. So
Yes.
I can just tell it to you if you wanna. I'm working on number 10, and that's secant x minus cosecant, cosine x equals sine x tan x. And
Okay.
I've knocked out some parts of it, but not like enough to solve it.
All right, then well, I'm going to pick a side. I'm going to start over here. So I know that this is equal to 1 over cosine, right? Minus cosine.
Yeah, that's where I got.
So this is over 1. So we can get them over the same denominator. Let's see what happens. Let's multiply this guy by cosine over cosine. So that'll be 1 over cosine still. I didn't change it. Minus cosine squared x over cosine x.
Okay, that's what I was doing wrong. Because I was like, where do I go from here? And I did not think to do that.
Yeah, the first thing you want to do is try adding fractions if you see them. Like once you created this, there's your first thought should be, well, combine them, add them up, or subtract them in this case.
Okay.
So now we have 1 minus cosine squared over cosine. And 1 minus cosine is sine squared, isn't it?
Yeah.
So
Okay,
from here
so-
to here, well, completely. Here to here, we added fractions. The beginning, we use the idea of reciprocals, or I think it was might have been ratio. Here, well, that was the Pythagorean identity.
Okay.
And we're almost done. So, do you agree that sine squared is sine x times sine x?
Okay. So.
Right.
I'm trying to like catch up and write it correctly.
Sure.
So. Also, the way they have you enter it in the homework is real stupid looking. Sine x.
Yeah, the homework is weird, but
You know what I'm talking about, right? Like,
mhm.
like the most logical thing when you have something that has fives all across it is like pull the 5 out and then work with the stuff left over. But in the homework, it doesn't let you do that. It makes you keep all the 5s exactly where they are. Get what I mean?
Yeah, the homework isn't great when it comes to this type of problem.
It's real dumb. But yeah, I agree with you that sine x times sine x is sine 2x.
So do you see that this right here is tangent?
Yeah,
So that means we can separate them because they're just being multiplied.
yeah.
So that'll be sine x tangent x, which is what we wanted to show. Here to here, we did the ratio, I think, identity.
Yeah. Okay, so there to there. Ratio. Okay, I had a couple more questions if you're open to it.
Sure.
So I've gone through like 3 chapters, so obviously there's some questions I missed.
Okay.
From chapter 7.1, I didn't understand. I got this right by guessing, and I don't want to get stuff right by guessing. So
No, I
I was
suppose.
thinking- what was that?
No, yeah, I guess not.
I would rather not get stuff right by guessing. Like, I can kind of eyeball it, but I don't want to have to eyeball it. I want to just understand and not be dumb. So for 7.1, question number 7, secant squared x minus 1 over sine squared x, and you gotta simplify that, I guess, like put it in its simplified form.
Okay.
Yeah.
So just to simplify this.
Yeah, the correct answer that I got at the end by guessing was secant squared x. So that's the actual final answer. But I don't know how I got there or how to get there.
Mhm.
Yeah.
Okay. Well, maybe, since I see a secant square, my first thought is Pythagorean identity.
That's what I did. But then I get stuck on the next part after that.
So this top part is going to be tangent squared, right?
Yeah, tangent squared x over sine squared x is what I got.
Cool.
And then the next part I got was in parentheses sine x over cosine x times sine x over cosine x, and put all of it over sine squared x. And
Yeah,
that's where I'm
good idea.
that's what I got, and that's where I'm stuck.
So we change that tangent and it's over sine, right?
Yeah. I separated those 2 things though.
What's that?
Yeah, I separated the sine square x and cosine squared x into, 2 different parenthesis bubbles of sine over cosine.
Yeah, that probably looks better. You want me to separate it?
I mean, follow your heart, sir.
That means these days. Let's see, divide by sine, how about that? Is that more clear or is that weird?
That's weird.
Is it?
I mean, you asked.
Okay, no, that's fine. Glad you're honest.
Yeah, I did sine x over cosine x in a parenthesis times sine x over cosine x, and I got rid of the exponents. Get what I mean?
Mhm. Yeah,
Oh
that's
no, I put them next to each other. Yeah.
like this, right?
Yeah, but I separated them on the numerator.
Oh, you skipped a step. That's what you're saying. So dividing is the same as multiplying by the reciprocal. So these will be gone, right?
Or hold on.
Isn't that what you said?
Not really, but you know, I can kind of see what you're doing. Which is the same.
You want to see another step? If I multiplied through, I'd have cosine squared times sine squared. Right? If you prefer.
I prefer nothing.
Okay, so real quick. 2/3 divided by 2 is the same as 2/3 times a half, right? Because this is over 1 technically. Just like this is over 1. Do you remember?
Yeah.
So when you divide fractions, you multiply, it's the same as multiplying by the reciprocal of the divisor, right? So here we're dividing by a fraction, technically, so you can flip it over and multiply and then reduce. So
Okay.
here, these would reduce, right?
Okay.
Does that make sense or no?
Nothing makes sense.
Where did I lose you? Like, what's bothering you?
So here, I'm just gonna write the way that I wrote it real quick, if you're okay with that.
Sure.
X. Because I don't think I did it wrong. I just don't understand how to make it better.
Well, you said you divided into this guy, didn't you?
I did, but it's the top part that you don't have written the way I wrote it, and I want to understand why that's different. You know?
It doesn't sound different at all to me. If you divide it into it, shouldn't they cancel on your end too?
I mean, it didn't make sense when I did it though,
Okay.
and I want to know why I'm all over. Okay, and that's how I had it. Do you get it?
Yeah, I'm looking at it now. Let me see. Oh, I
Oh.
see. You reduced the, you broke the sine squared with cosine squared into sine cosine sine cosine.
Yeah.
I mean, I guess that's not wrong,
But why did I
but
not?
it's useful.
Why did I not?
Well, if you want to do it your way, we could do this, I suppose. But what you did is not algebraically incorrect.
It's not?
No, it's not. There's nothing wrong with it.
Okay.
It's just a different path that may be longer or just a little bit more roundabout. At the end of the day, it doesn't really matter. So you said that this is sine basically twice, right?
Yeah.
Like this? Is it cool if I write it like this?
Yeah, that's how I wrote it.
Okay. And then
On
you have
top
line
of
down here.
Sine squared x. And that's where I got stuck and I couldn't figure anything out.
Okay. Well, the thing is the same issue. This sine is divided into both of these, right?
Yeah.
Or technically this is one term, really. This is the same as saying sine x, sine x, sine x over cosine, cosine, right?
Yeah. Yeah.
So if you divide this, you're going to end up doing the same thing I showed you earlier. You have to multiply by the reciprocal of this sine. Like no matter what, you got to go here.
Okay. So that would still apply.
Yeah,
It
it's
would
still
work.
fine. So now we have a sine squared on the bottom. But you see how either way it would have canceled the two sines, right? Because we have sine squared down here. So that's the same as both of these.
Okay.
So breaking them up didn't really help like this, but it didn't really mess anything up either.
Just, my brain.
What's that?
Just my brain. Okay. So,
You just you added an extra step that didn't really hurt anything.
at least I didn't do anything fundamentally incorrect. That makes me feel better.
Yeah, it wasn't incorrect. You tried something and then you weren't sure what to do next. But the idea is you try anything and see what happens. And if it doesn't work out, try something different or see if you can do something with that step. And here it looks like you still can. So we're going to end up with 1 over cosine, which is secant.
Okay. That makes
Yeah.
more sense.
But if you would have left them together, this would have canceled it right away, right?
Yeah.
So that was the actual thing you did. That's it. Right? Does that make sense though?
Yeah, it makes sense now. I'm just frustrated that I was dumb. For number 10 in 7.1, sir. Number 10 in 7.1. It's tan squared x minus tan squared x
Hold on a second.
multiply. Yeah, problem 10. I'm
Mhm.
sorry?
What
Oh,
was
you're
it?
still recording, by the way. I don't know if you want to still be recording.
That's fine.
Okay. This is tan squared x minus tan squared x minus.
Minus
Yeah.
tan squared x?
Yeah, minus tan squared x
Oh, okay. Weird.
times sine squared x.
Like this?
And yeah, just like that. And the answer I got was tan squared x cosine squared x. But the homework said I was wrong. But I factored out the tan and then I did Pythagorean identity, and that was my solution to it.
Yeah, that sounds like a good idea, actually. So you factored tan squared, right? And you got 1 minus sine squared.
Yeah,
And then that became cosine, correct?
yeah.
Which will then cancel the cosine inside the tangent.
Oh, that's what I did wrong. I just didn't finish it, basically.
Yeah, you weren't finished. So that was a great idea. And then right here, you're done.
Okay, so that's sine squared x. I had a lot of trouble with not 7.1 necessarily, but the one right before it. That one was like a struggle. But get to that in a second, I guess.
Okay.
One more on 7.1, sir.
Okay.
For 7.1, problem 16. Yeah, for 7.1, problem 16. I had trouble with, so in parentheses, 7 cosecant x plus 7, parenthesis, another parentheses, 7 cosecant x minus 7. And at the end of all of this, the answer I got was 7 cotangent squared x, and that turned out to be the wrong answer, but I did my best, I swear. I factored out 7, so I got 7 out. That was what I did. And then I guess I basically foiled the other two together, kind of. Or,
Yeah,
rule
well,
of
they both
cubes.
have a 7 in common. So you'd have to factor 7 and then 7 again.
Yeah.
But you see, this is a difference of squares though, right?
Yeah, that's what I did. A difference of squares. I said FOIL when I meant that.
Yeah, yeah, I mean, it's the same thing, right? So you should have, if you didn't factor, you would have had 49 cosecant squared x minus 49.
I factored out the 7 though.
That should be your answer.
Oh, did I have to distribute the 7 back in?
No, I mean, if you factor the, I mean, it's supposed to be a 49, not just a 7.
Mm,
Do you see
what
why?
I ended up doing was I took the 7 out and then I difference of squared the leftovers. And then that gave me 7 parenthesis cosecant to the squared x minus 1. And then I took the cosecant squared x minus 1 and I applied one of the identities to it, which gave me cotangent. There's a square, yeah.
You see what I mean? There's 2 7s.
Oh, I thought I could just apply the 7 across everything. Okay,
You
that's
could if
probably
there
where I
was,
got wrong.
if there was an addition here. But
Okay,
this is all products. So you have a factor of 7 here and another factor of 7. So you actually have to pull out 49. And then you can do your multiplication.
so you pull out 49.
Because I got to pull out a 7 from each of them, which is 49.
Okay,
So that's how you get cosecant squared x minus 1.
and then that just ends up being the cotangent, right?
I believe so.
So it's actually 49 cotangent squared x.
Mhm. You had a 7.
Oh, so I was like, I was doing it right. I just missed one of the 7s.
Right. Yeah, yeah, I just made a factored error there. Everything else was good.
Okay. Would you give me like pity points for that?
You should deserve most of the points there.
Okay. I'll take pity points. Okay. Then for chapter 6.7, sir?
Well, one for this section too.
Oh,
What's
you
up?
do?
Yeah,
Okay, sure.
honestly, I've been like avoiding this because I thought I was the only one that was this far behind.
Oh no, I fucking work for the military in a hospital. I'm like constantly behind.
Oh no, I get done respiratory therapist with 2 jobs. I have mutual respect for you over there. So number 8, cosine squared parentheses pi over 2 minus x.
Hold on a second. Let me write
Oh,
down.
sorry.
What was it?
Cosine squared parentheses pi over 2 minus x.
Pi over 3 minus x.
2.
Pi over 2 minus x.
Like that, or was this inside the cosine?
The cosine squared x isn't in parentheses.
Okay, so but
Yeah.
this is the argument though, right? Of the
It's
cosine.
not the x. Like the cosine 2x, the pi squared minus x is the x for that cosine squared.
Yeah, I didn't mean to say cosine 2x. That's my bad.
Gotcha. Yeah, that's what I thought you meant. Like this, right?
Yes, over cosine x.
Okay.
Which, okay, so the top should, and here's what's messing me up. The top should be able to be sine x, but the square is messing me up. So could it still be sine squared x?
Well, I think it should be, but if we're not sure, we could separate it, right? And just have 2 of them.
Oh. I think I made this a lot harder than it was supposed to be.
So the property says that this is sine and that's sine, right? I believe, but right?
Yes.
Okay, 'cause I don't have that formula in front of me, but I think that this is equal to sine. And so is this. What were the instructions, by the way? What they want us to do?
Simplified form.
Okay. So I think the simplest that I see would be sine times sine over cosine, which would be sine tangent.
I've been scared of that.
Did you think it was?
Thank you. A lot harder than that, yeah.
Yeah, it looked weird at first. I'm not gonna lie. When you first said this, I'm like, how the fuck do I do this? But now I'm like, okay, you know what? We know what that is. So once it's transformed, it's not too bad. But I see why you felt that way.
Okay.
Did you have another one, Rebecca?
Nope, that's it on that one, on that chapter anyways.
Okay. I had one actually. It's not 7.1 anymore though.
All right.
So
What section is it?
it is 6.7, sir. So this is more of like an issue with me not knowing how to do something with my calculator. I'm pretty sure I have the right answer. And I know because I checked this both with the application of cosine B or whatever, but I also checked it with the Pythagorean theorem and I get the same answer either way. So I'm pretty sure it's the right answer. I just don't know how to turn it into decimal form. For question number 5, it's solving a right angle for
Number
all
5?
sides. Huh?
Number
Yeah,
5?
question number 5. I got everything right except for side A because it wants me to put it in decimal form, but my calculator keeps on spitting out 8 square root 3 and I can't make it. I don't know how to turn it into a decimal.
Oh, okay. But are you sure it's correct? You just don't know why it's how to change the decimal?
Yeah, because I got every other number correct, like every other number correct, which leads me to believe I'm probably right. I just can't make 8 square root 3 into a decimal on my shitty little calculator.
8 square root 3 into decimal.
How did you do that? How did you do that?
I just pressed this button right here.
What button?
This button above the equals or the enter.
Above the enter?
Mm-hmm.
Oh, okay. So you put 8 square root 3 and then press the button above the enter?
Right. And then you can press it to go back if you want to.
Huh. Okay, let me try that. I just want to make sure I know how to do that.
Like 1 divided by 3 is that, but you can also get a fraction. Or either or.
Oh, okay. Okay. Let me write that down really quick so I know how to do that. Okay. Yeah, that was just me not knowing how to use my calculator. Like, that wasn't me necessarily doing my math wrong.
Gotcha.
I'm glad you understand what I mean by that.
Yeah, it happens. I mean, like I don't know how to use that Inspire that Becca uses. Takes me a few minutes just to do some basic stuff.
I don't know how to use it either. Don't feel bad.
All right.
It just takes time.
Um,
I don't know, I already used like 3 different ones. I don't really feel like learning a 4th one right now.
okay.
But I'll
There
take
was
your calculus class next semester. We'll learn how to use it together.
I don't know, like I need to, but yeah. I
There
think
was
these
another question.
we're required to use that for statistics. So if I teach stats again, I'm gonna have to.
Good luck with that, sir.
Yeah. Eventually.
So question number 8, sir. I only got one thing wrong, and I don't understand how I got it wrong. Okay?
Same section.
Yeah, it's the same section. It's 6.7 still. I'm just going backwards in the chapters right now. So for question number 8, they give you like a side and an angle, and they're like, find the rest of it on this triangle, on this right angle, right? Right angle triangle. So I got every answer correct except for angle B. So I'll tell you all the rest of it, and then I'll tell you what I got for B, okay? So
Okay.
for all the rest of it, all that was correct was A is 77.45. C was 90. A was 54.81.
54.
54.81. B is 12.20. And C is 56.15. So I got all of that correct. And then I got for the angle B 12.54, and apparently that's wrong.
Well, did you subtract from 180?
I did. I tried that, and I tried the cosine inverse thing. You know, cosine B equals 54.81 over 56.15, that thing.
You got 12.55, you said?
Yeah, I got 12.54.
I got 5.5.
Am I seriously off by that?
I don't know. Try it. Could be. And that would be hilarious, but
That's really dumb. Because that last digit half the time is like, anyways,
did it work?
I didn't enter anything, so I don't know. But I don't know if the homework would have accepted that or not. But I did all my other math correctly. Like when I enter the numbers using cosine inverse of 54.81 over 56.15, you know, practicing the actual like thing.
Mm-hmm. So you tried to use law of sines on this guy.
Yeah, because you know, I'm just practicing it. I know I could for a right angle do the 180 thing, and I did, and I got the same answer. But I wanted to try it this way because this is like practicing the fucking smart person way.
Yeah, we can do law of sines. You want to do it for fun?
Yeah, I got the same thing. 12.5424576. Look, if I have a 12.542, because of that 2, I kept it as a 12.54. You know what I mean? Like I rounded, when I round with a 2, I keep it as a 5.4. I don't round up.
Oops. Hold on a second. Yeah, let's plug it in and see what it gets.
You know what I'm talking about, right?
Yeah, you said when you actually did the whole work, you had 0.2 at the end, right?
Yeah, like 542, 0.542. And so I kept it as 54 at the end of 12.
All right, let me see if I get the same thing. Over 56.15. Did they say on the instructions, did they say anything about how to, well,
How to round it?
yeah, did it say anything about rounding or like
Yeah,
process?
it's 2 decimal places.
Did it say anything else?
Nope.
Oops. Dang it. Where is sine inverse? Oh, that's right. My bad. I forgot how to work this thing. 1 second. No, it's a 5.49. You said you got a 5.2, 5.42?
Yeah, I got okay. I'll just tell it to you exactly how I did it. I did cosine of angle B equals 54.81 over 56.15. And then I took the cosine negative one on each side to get
What
rid
about the little b?
Huh? The little b? The little b. I don't know.
Did you solve for sine b?
I didn't use sine, I used cosines.
Oh, wait, hold on. So what formula did you use?
I used cosine b.
Oh, okay. I'm sorry. I thought you were doing law of sines.
No, I did
You're
cosine.
using this guy
Yeah.
equal to cosine inverse.
54.81 over 56.15.
Write down the
Don't
form.
ask me why I was using that. I have no idea why I was.
It's just for fun, right?
Yeah, I guess.
So that will be 55.81 squared plus 56.15 squared minus 12.2 squared. 2 times 54.81 times 56.15. Okay. Sorry, I wrote that all weird, but cosine.
Hella not what I was doing.
No, that's the formula for B.
That was hella not what I was doing though.
What did you do? That did you do this nonsense and then do cosine inverse?
I didn't do any of that.
Okay.
Here, I'll write down exactly what I did. I did B.
Yeah, maybe I'm not understanding at all what you did then.
Probably. That might be it. Cosine one.
You know, what formula did you use?
I did that.
$54. Why did you do that?
I have no idea, sir.
Yeah, I don't know what formula that is, but I don't think that's right. And you got
See, on the
close to the
previous
answer?
chapter, I did. I got 12.54. So clearly it got me pretty damn close.
I think you did. I think that's black magic. Yeah.
Sure. Anyways, I think on the previous chapter, the one where I actually did really struggle
Mhm.
is probably why I got that answer like I did there. Like, I did not really understand the previous chapter all that well. I guess let's go to that one then.
Okay.
It's kind of amazing I got as close as I did though.
Yeah, I'm trying to figure out. I mean, most likely it's a coincidence, but I'm trying to figure out if there's a reason why it's close.
Isn't that the art cosine chapter that we did?
I think you already went over that one with me.
Oh, wait a minute. Did you use the definition of cosine? Is that what you did?
Yeah, I think so.
So you said, okay.
Whatever.
I think I
seems like
understand now.
thing.
Sorry, I'm a little slow.
You understand what I did now?
Mhm. So did you call, I'm gonna call this guy adjacent, I guess. $54.81. Here's theta.
I mean, that makes sense, right? Kind of why I would do that.
Yeah, I see what you're saying now. So you're saying that cosine theta is equal to 56.15 by definition. And then you said that theta would be cosine inverse of this. So yeah, that's legit. I'm sorry.
You all judging me.
No,
You're
I
the one
thought
who
you
taught
were,
me that shit.
I wasn't sure what you did. That's all.
Calling you out,
What
sir.
exactly you were doing.
You're the one who taught me
I
that.
thought you were doing witchcraft, but now I see.
What is teaching the shit you fucking taught me, Dumbledore?
Let's see, my bad. It's not dark magic. Okay, so the reason why it was wrong, and that's what you really want to know, right?
Yeah.
It's because of this using this. Okay, when it comes to calculations in general, like in any calculation, every time you round, you lose accuracy. So you rounded here. So when you're using this, you have lost accuracy. So when this answer came out, it had lost some digits. That's why it did not round up to 5.
Damn
It
it.
stayed at 5.4. So if you would have kept some extra digits here, usually what they recommend, I know it says round to 2 decimal places, but you round at the very end, not during the calculations.
Huh.
So like sometimes
lied
it's
to
better
me,
to have
man.
extra digits here, or sorry, in here when you're going to do the actual inverse. So if you notice when I use this one, when I use these two formulas, it came out correct because this had a little bit more accuracy because I had sine 90 in here.
Yeah.
And that's an exact number. Here, it might not have come out. Maybe. I'm not sure. I didn't finish it. But yeah, that's why. You weren't wrong. Your idea was great. Nothing was wrong with it. It's just rounding error. That's what it was.
Okay. Sir, can I make a request?
Sure.
So I don't have to like do a whole new problem with all of that all over again when I'm already behind on so many chapters that I'm trying to catch up on. Can you please let me have credit for that part?
Yeah.
Like,
What number was it? 8?
it's problem 8 on 6.7. Can I just, because my heart was in the right place, and then I was like mostly doing my math right. I just was off by 1 decimal point because of rounding stuff. Like, and then for number 5, I just couldn't use my calculator to turn 8 square root of 3 into 13.86 because I didn't know how to use the calculator.
Well, I'm glad some of these problems were not because you didn't understand.
I know, right? Isn't that like, doesn't that make you feel good as a teacher? It's just because I don't know how to use my calculator, not because I didn't understand the math.
Yeah, that's good news.
Yeah, like that, it feels nice. So out of all of the chapters that I've worked on today, for whatever reason, 7.1 is the one I struggled with the most. Oh, here's another request, sir, for 6.7, which is also like, I think, just a really stupid error. For number 13, and I don't need you to do any math. Number 13, when I entered the answer, I accidentally put a comma instead of a point. So when it should have been 5.68 seconds, it ended up being 5.68 seconds, which is obviously wrong. So that was just me entering it wrong. Could you please let me have that? Do you understand what I mean?
Well, I'm trying to give you that point real quick. One moment.
There you go. I'll take all the points I can get, man.
I just forget how to do that. That's all. 1 second.
I'll let you practice, really. Like,
I'm gonna work around. I'm gonna give you 2 bonus points for the 2 points you lost. There you go.
okay. Because
You're being this giving and take off all the partial fraction decompositions. I'm okay with that too.
like,
The final, or what are we talking about?
All of it,
oh
all of the fractional partial decompositions.
yeah, decomposition. But for 6.7, number 13, I put a comma instead of a decimal point by accident before I submitted, and that marked it as wrong. It should have been a period. 5.68, not 5.68.
On 13?
Yeah. Do you see what I did?
On 6, 7, or which one?
On 6.7, number 13. I accidentally put a comma.
It says you got it right. 13.
No. One of them, it marked me wrong. So there's the 250 feet part, then there's the A and B part, and I got those right. But then there's the find the minimum amount of time it takes in seconds for a car to get through the zone thing. And instead of putting 5.68 seconds, I put 5.68 because I was half asleep when I was doing this.
It says you got 100 on that homework, so I don't know what's going on.
What? Anyways, I'll just accept it. Okay. On my thing, it's telling me I got it wrong.
My grade book says you're good.
Okay. The chapter that really like made me struggle though was like 7.1 and 6.7. But I guess I did them well. Those, you answered all the questions I had for those.
Yeah, I mean, it looks like you technically were passing those sections.
It's just the way they ask us to enter it is really confusing. I'm gonna submit this really quick. Will you stick around in case I get stuff wrong for a second? I only have to enter this question number 10 for 7.2 and then submit it, and I'll find out if I entered it right, which is a whole other question. Sin X. And then that was all right, I'm gonna submit it and see how I do.
Okay.
How quick does stuff like submit and show up for you?
On mine?
Yeah. Okay, I missed 2 questions on 7.2. I missed number 5 and number 6. I don't know how.
All right, have a good night, Joseph. You said 5 and 6?
Yeah, for 7.2. I just turned it in. I missed 5.6. And I don't know how. They do it real weird.
Did you want to share your screen or do you want to do it from the beginning?
Can we do it from the beginning, maybe?
Which one?
That is number 5 on 7.2. Basically, what it wanted me to do was verify the identity of 5 cosine squared beta minus sine, minus 5 sine squared beta equals 10 cosine squared beta minus 5.
Cosine squared?
Yeah, cosine squared beta minus 5.
All right, so,
I got it partially correct.
oh, I see what they did. Okay. So we'll start here. Change the sine into a cosine. So right here is going to turn into 1 minus cosine squared,
So 5.
right? I'm changing
Yeah.
the sine into 1 minus cosine. Is that okay?
Yeah, I think so.
So now distribute. So it'll be negative 5 plus 5 cosine. Right, negative 5 times 1. Negative 5 times negative cosine. Add them together. That's 10 cosine squared minus 5.
Okay, I hella didn't do it that way. I mean, I still got the same answer at the end, but I did it very differently.
Yeah, there's many paths to the end. Some are shorter.
Like doing it the way they want me to do it is hard.
Let's see, number 5.
Wait, where? What is the actual like?
Let's see what they did.
Let me see.
Yeah, that's what they did on at least
Okay, so 5 cosine minus 5.
pretty much what I got. What they did. See.
Okay, so 2 beta. So it's just cosine 2 beta and cosine 2 beta are literally just the answers.
What's up?
So annoying. Could I see your paper again, sir? Thank you. I'm just trying to make sure I do this right. Okay. 5 cosine theta, 1 cosine theta. Okay. All right. I think I understand it now.
Okay. Cool.
All right. And then 6, the other one I got wrong.
Okay.
And then I guess we'll just call it a night.
Yeah, it's almost 10. But what's the question?
For number 6, it's 2 sine squared alpha minus,
I'm gonna use theta.
okay, minus 2 sine 4 alpha, I mean theta.
Like that?
Oh, no, exponent 4.
Oh, sine to the fourth. Okay.
Yeah. Equals 2 cosine squared theta minus 2 cosine to the 4th theta.
Shit.
I do that shit all the time. Erasable pens are my jam.
Yeah, same. All right, I'm gonna try to start with this side.
Okay. Because I got the right answer again. I just didn't get the answer that they want inputted into the thing.
I'm gonna factor 2 sine squared, giving me 1 minus sine squared. Which would be cosine, right?
I can't see what you're doing.
Sorry.
Yeah, I got there.
And then we could change this guy, I suppose, into 1 minus cosine for no reason. And then multiply this guy. That'll give me cosine squared minus cosine to the 4th. Distribute the 2. There we go. That's what they wanted. We wanted to show. So factor, change them to cosine, change both of them to cosine, then multiply them back together.
Huh. 1 second, sir. I gotta write down. Apparently, I like missed a step. It's really frustrating when I get really close to the correct answer. Do you know what I mean?
Say that again.
Like I'm so nearly there.
That's a good thing.
I know, but it's really infuriating. Like it's so angering that it's like right there.
It's better than being completely lost, right?
Yeah,
I
Just
feel like
double-
that's the worst feeling.
that's very accurate. Sir?
Hmm.
Real quick. So when in the row that is the third from the bottom, that row. Yeah, that one. So when you have that 1, just double checking. How are you getting rid of that 1? Are you distributing the cosine on the other side? The cosine squared on the other side?
Yeah, doing cosine times both.
Okay. Thank you.
So cosine times 1 is cosine squared. Cosine times cosine squared is cosine to the 4th.
And what are the 2 things they want me to circle here? So I got the first one right, but the second one I got wrong.
Looks like we have the same one. They want you to put sine in here and then 2 cosine.
Oh, Oh, I just missed a 2. Where did the 2 come from? Wait, how is there 2 cosine there? Did I need to distribute that 2?
Yeah, they left a 2 in and I factored it, I think.
Yeah, I factored it too. That's why I was confused.
I guess, right, on this step, they went ahead and put, well, yeah, that's weird. I don't see what they're,
That's why it confused me. I still did it right. I just,
I think our way is better.
yeah. Because their way is stupid and difficult.
I don't like that either.
I think that's everything I had to ask tonight, sir.
Cool.
Is there any chance I could ask you stuff tomorrow?
Tomorrow, it's, no, probably not. But tomorrow is Friday. I'm gonna be busy.
Okay, that's fair. I just thought I'd take a chance and ask.
No, that's okay. They have meetings and then I have, no one be around in the evening. But Monday or Tuesday will be fine.
Okay, but the test is on Monday, sir.
True.
Anyways, at least I'm most of the way caught up now, or at least halfway caught up now.
Yeah, you're making great progress. I think you'll be okay.
Okay. Thank you, sir. You have a good night.
You too. Good night.
Sleep well.
Have a good night.
You too.